So now let's have a look at the second question for lab 1. So now we have a class called polynomial, and it is able to do two things. One is return the equation for the polynomial function. The second one is to evaluate given the value of x. So the constructor seems to have two things. One is a degree, another one is coefficient array. Degree, we will use it to indicate the highest power that the x can have in our polynomial function. So if it's 3, then the highest will be x cubed. So coefficient in array, it means it will be sorted in order. So for example, the first one is 4 here, then the second is 2, then the third one is negative 0.5, the last one is negative 20. So that is it. I have already constructed the basic structure of our polynomial class, which we store the degree and the array of coefficients. And we'll have two methods. One is to string to return the equation, another one is evaluate, which evaluate the actual results. Now, let's implement this first. Equation equals to, at first it's an empty string, then how many times we want to loop? Less than or equals to degree I plus plus. Why am I doing this 4 times? Let's say if the x degree is 3, right? So we will iterate for 1, 2, 3, 4 times exactly. So here we need to iterate 4 times, and for every iteration we will first of all plus the array of index I, which is the coefficient first, then with the x sign and the power sign. Then after this we'll have a degree minus I think. Yeah, at first it's 0, so it should be degree minus I, then the equation plus equals to a plus sign. I think it should be okay. Then at last we return the equation. This one I return 0 to avoid an error. First, let's try to run the test case. This is a test case exactly the same as the question stated. So if I run it, see if our two-string method is working properly. Yeah, it's working properly. Yeah. So 4x cubed, 2x squared, negative 5x, and the negative 20 with x power of 0. So now this is the current equation which I made, but definitely it will need some improvements. For example, the last iteration should not return the plus sign, and if the x coefficient x power is 0, it shouldn't be printed also. And also, let's say if our coefficient is 0, so the entire section should be ignored. Let's say if the negative 0.5 here is not 0, so this entire thing shouldn't be even printed. Yeah, this kind of improvements you need to consider, then you need to do some modifications in the iteration part. Yeah, do some validation maybe. Now, let's go to the evaluation. Before continue with the evaluations, I'm going to show to you one method which is called Horner method for the polynomial function evaluation. Yeah, given the x value. So let's say we are using this equation that we have here. So these things I don't need. Okay, this is the current stuff. Current equation. Okay. So now this is actually equals to, if we group the x together, we'll get a 4x, oh shit, 4x cubed plus 2x minus 0.5 minus negative 20. So we can even further group the x inside. It will become plus 2 here. Then this is a group minus 0.5, I put it here, minus 20. So this thing will be exactly the same as this thing. We just group out the x together. So this is called a Horner method. And we can clearly see the substructure inside, which is something like a recursion. Let's look at the deepest bracket first. This is 4x plus 2. The 4 is the first coefficient, then the 2 is the second coefficient, then this is the x value. After we calculate this, we will multiply again with x and plus the next coefficient. Then after evaluating this, we will multiply with x again and plus the next coefficient. So by using this logic, we can actually construct our evaluate method within one iteration, which is the complexities O(n). Yeah, that's one iteration I can find the answer already. So in order to construct this, first we will initialize the result and put our value of the first array, which is the 4 here inside first. Then how many iterations we need? Per thing. I equals to 0, I less than the degree, I plus plus. So degree is 3. If degree is 3, we will need 3 times. We can iterate for 3 times. So this is the first time, this is the second time, and this is the third time. Yes, exactly, we will need 3 times only. So the result is 4 currently. 4 you need to multiply by 4 by x. Then need to plus with the coefficient, the next coefficient, which is the I plus 1. So this is the result. Then we'll iterate 3 times, blah blah blah. After that, we'll return our result here. Let's validate if our evaluate function is working properly. Now we get a 19 and negative 165.25. So 19, 165.25. Well, it works. So that's it for the question 2, equation and the evaluation by using the Horner method. Right, yeah.